Hi ladies, this is lesson 5.2. It's about exterior angles of the polygon. So last lesson we measured and kind of found a general formula for measuring interior angles of a polygon, but this lesson focuses on the exterior angles. So if you remember from our triangles, so if this is our triangle, these three are the interior angles. But we also have exterior angles. And that would be if you extended one of the sides. This would be an exterior angle. And again, if you extended one of the sides, this would be an exterior angle. And again, if you extended one of the sides here, you would have an exterior angle. That is one set of exterior angles. Now you could go the other way and come up with another set, but that is one set of exterior angles. So to start off, we're going to find the measures of the lettered angles. So we're working with interior angles and exterior angles. So you can do this a few ways. You can't necessarily go in alphabetical order, but if you wanted to start with A, you could do that. Because A and that 60-degree angle here, they form a linear pair. So you could start there. Or if you can remember some properties back in chapter 2 or chapter 3 about corresponding angles. You notice these two are both 90 degrees and they're corresponding angles. So if corresponding angles are congruent, that means you have parallel lines. So in this case, these two lines are parallel. So if these two angles are corresponding angles and they're congruent, we also know that those two angles are congruent. And you know that this 60-degree angle and C are congruent because they are corresponding angles. And you know that A and B are congruent because A and B are alternate interior angles, so they're congruent. So you know that A equals B, whatever B is. You know that C equals 60 degrees. And you know that D equals E. And E also equals D. So let's find E or D. And again, you can use the linear pair conjecture to come up with that. And so E and D are both 90 degrees. And with angle A, you can use the linear pair conjecture with a 60-degree angle. You know that A and B are congruent. So 180 minus 60 is 120. And C, you know, is congruent to that 60-degree angle, so it's 60. Now, if you didn't recognize that these were parallel lines, you can still solve this problem. You'll just have to do a different method. So, you know that E is 90 degrees because it's a linear pair with this 90-degree angle. And same with D. You know it's 90 degrees. You can use linear pair for angle A also, and you get 120 degrees. But now you don't know angle B or angle C. But what you do know about angle B is that all four of those have to add up to 360 degrees because it's a quadrilateral, it has 1, 2, 3, 4 sides. So you know that it has to be 120 degrees. So 360 equals B plus 90 is 180 180 plus 60 is 240. So then if you just solve using algebra, you get 120 degrees for B. And then if you use linear pair conjecture, you can get C at 60 degrees. So if you recognize their parallel lines, that's a little bit shorter. But if you don't recognize their parallel lines in this problem, you can still solve. So now let's look at the sum of the exterior angles of the quadrilateral. So the exterior angles, those are angles A, B, not B. B is an interior angle. So A plus C plus D plus this 90-degree angle. So I'll just highlight those exterior angles so you can see them. Exterior, we should use yellow. Okay, so we've got an exterior angle here, exterior, exterior, and exterior. We have 4 exterior angles. So that is one set of exterior angles. So if we add these all together, we have A is 120, C is 60, D is 90, and 90. So if we add those together, we get 360 degrees. So in this first example, the sum of just the exterior angles of the quadrilateral is 360 degrees. So these were what we just did, looking at those exterior angles. Those are called pinwheel polygons, and those are polygons with one set of exterior angles. So if you think of a pinwheel, the arrow points like in the same direction, like a continuing line, the arrow points in the same direction. So you want to do it like this. So if this is your polygon, that goes bad. Let's try that again. If this is your polygon, you want to extend the same way every time. So extend this line so it looks like a pinwheel. Okay, with a triangle, and that's the example that we did at the beginning. Extend the same way so it looks like a pinwheel. If you do it like this, where you extend both lines, you have 2 sets of exterior angles. And for this one, like it should be this way. This one is mixed up. So you want to do it like these ones. So it looks like a pinwheel, not like these. Okay, so I'm going to pause the video, or you're going to pause the video, and you're going to take out your protractor, and I want you to measure the interior angles of the polygon. Use the linear pair conjecture line to find the measure of the exterior angles, and then find the sum of the exterior angles. So your pentagon, once you measure all the interior angles, that should give you a total sum of the interior angles of 540 degrees. Hexagon, you should get for interior angles 720 degrees. Then use the linear pair conjecture to find each of these marked exterior angles. So these are pinwheel polygons. Both of these polygons have one set of exterior angles. So pause the video while you do that, and then you can unpause for the solution. But you really should be practicing using your protractor, because again, we haven't used it for a while, so practice using your protractor because you will have to measure angles on quizzes and tests. So your first step, measuring all the interior angles, here are the measures you should get. And then your next step after this is to use the linear pair conjecture, which says a linear pair, the angles in the linear pair add up to 180. So use that to find those red exterior angles. Once you find those exterior angles, add those together. And when you add those together, for both of these, you get 360 degrees. go back to the idea of the pinwheel. If you think of a pinwheel, you put it in your yard and the wind spins it, or maybe you blow it, and it goes in a complete circle. That is the sum of the exterior angles for any one set of exterior angles for any polygon. So whether it be a quadrilateral, or a triangle, or a pentagon, or a hexagon, or an n-gon, the sum for any polygon, the sum of the measure of one set of exterior angles is going to be 360 degrees. All right, let's try this next example. We're going to use the exterior angle sum conjecture. You can use other methods, but since we're practicing with this conjecture, we're going to use that. So the first thing we need to do is get one set of exterior angles. So we're looking for x, y, and z. This happens to be a quadrilateral. So we're going to extend the angles, all four angles in the quadrilateral. All right, so this first one, let's extend this way, and here's our exterior angle. And we're going to go along like a pinwheel. Okay, so we always have to extend the same direction. Alright, so those are your four exterior angles. Now if you notice that little triangle where that line XY splits that triangle into two shapes, it splits it into a quadrilateral and a pentagon. You look at this triangle here. This triangle is marked as an equilateral triangle. An equilateral triangle is also equiangular. So we actually know the three measures of this triangle, of the interior angles. They're all equal, so they're all 60 degrees. So if we know the exterior angle next to x is 60 degrees, we can also, and we know that whole triangle, each of those angles is 60 degrees, we can use the vertical angles conjecture here. So we know the exterior angle next to y is 60 degrees. We can use the linear pair conjecture here. So we know the exterior angle next to that right angle is 90 degrees. And let's just call this angle here A, because we don't know it yet. So we know that 60 degrees, that's the x angle, exterior angle next to x, plus 60 degrees, that's the exterior angle next to y, plus a, which is the exterior angle next to z, plus 90 degrees, equals 360 degrees. So let's see, 120, so that's 210 plus A equals 360. So A equals 150. Okay, now we can kind of work backwards, and we can use the linear pair conjecture to find x, y, and z. So 180 minus 60, that's 120. Again, here 180 minus 60 is 120. 180 minus 50 is 30. And this one is 90 degrees. And so just to double check our answer, we can make sure that those add up to 360, which they should. So 120, that should all equal 360. 240, so that's 270 plus 90, which is 360. So that works out. So you could also do this using the linear pair conjecture and some of quadrilateral interior angles conjecture. But this is just showing that there are multiple ways to solve a problem. So if you get stuck on one method, it's not working for you, try a different method, because we're going to go through a lot of different ways to solve these kinds of problems. So your homework is listed here. It's also on your note sheet, so please jot down any questions you have, and we'll discuss them in class. Thanks.